These two animations demonstrate the difference between basic layer movement and true 2.5D depth. On the left, the foreground object slides independently of the background. On the right, the entire scene moves in a cohesive three-dimensional space. The immersion on the right is the result of camera calibration. This process functions as a virtual tripod, precisely replicating the lens settings and the physical position of the camera that captured the original photograph. We establish this position using a reference grid. This three-dimensional grid layout maps out the virtual camera's alignment with the original shooting angle, providing a set of geometric coordinates that must track exactly against the floor of the image. To perform this calibration, you need an image with a clearly defined ground plane, such as a street or a floor, and a compositing environment like Adobe After Effects. Mastering this setup ensures your foreground elements stay anchored to the environment. This technical foundation prevents objects from drifting during camera moves and is the first step in building a realistic three-dimensional scene from a static photo. Step 1 is to duplicate your image and set the top layer as a guide layer. In After Effects, a guide layer remains visible in your workspace for reference, but is automatically excluded from the final render. Lower the opacity of this guide layer to 30%. This creates a translucent overlay that acts as tracing paper, allowing you to see the three-dimensional workspace you are building directly behind the image. Next, create a new 3D camera layer. For most standard photographs, starting with a 35mm or 50mm lens preset will provide a baseline for the virtual perspective. This setup creates a non-destructive framework. You are building the scene geometry based on the guide layer without altering the original pixels of the photograph. Start by creating a new white solid layer and apply a grid effect. This high-contrast pattern functions as your spatial reference map. Toggle the 3D layer switch for the grid to bring it into Z-space, the dimension representing depth. To orient this as a floor, set the X rotation to -90 degrees. This forces the grid to lay flat, establishing your ground plane. Ensure you do not change the Y or Z rotation values. Any adjustments on those axes will warp the grid and cause the virtual floor to tilt, breaking the perspective of the scene. Now, switch your workspace to Custom View. This provides an objective, external perspective of the three-dimensional scene, allowing you to see how the camera and the grid are positioned relative to each other. Move the grid down on the Y-axis until it aligns roughly with the ground shown in your guide layer. The Y-axis controls the vertical height within the 3D workspace. Switch back to the active camera view. You will see the grid now appears to recede toward the horizon line of your photograph. This mathematical ground plane ensures that the virtual space obeys physics. Objects placed on this grid will stay grounded to the floor, preventing the floating effect common in poor animations. Scale the 3D grid up until the pattern fills the entire frame of your composition. In the active camera view, compare the grid lines to the natural perspective lines in the photo, such as a curb or a building space. If these lines are not parallel, your virtual camera does not yet match the original lens. Adjust the camera's zoom or angle of view settings to change how the lines converge. The angle of view determines the visible extent of the scene. A wider angle causes lines to converge more sharply toward the center. This begins a repetitive refinement cycle. Adjust the camera's field of view, reposition the grid's Y-axis height, and rescale until the lines align. Continue this process until the virtual grid lines are parallel with the photograph's vanishing point. The vanishing point is the specific coordinate on the horizon where all parallel lines appear to meet. Achieving this exact alignment provides the structural stability required for a professional environment, ensuring the virtual camera sees the world exactly as the original photographer did. Select the Unified Camera tool to perform a tracking test. This navigation feature allows you to move the camera through 3D space. Push the camera forward along the Z-axis to test the alignment. If the calibration is accurate, the grid will stay locked to the photographic floor. The virtual geometry and the original pixels are now moving in perfect unison. This visual alignment confirms the depth is correct. When the grid remains anchored during a camera move, it proves that the virtual workspace accurately represents the physical space of the photo. Now that the geometry is locked, you can begin the next phase of the workflow, cutting out characters, placing them at different depths on the grid, and projecting the photo textures onto your 3D planes. The photograph is now a mathematically sound environment where every object occupies a verifiable point in space, providing the necessary foundation for cinematic animation.